Hello everyone, welcome back to the channel. In today's video, in the continuation of our JEE Advanced series, we'll try to dig into this one and solve and see which option is correct. Right? Now in this question, we are given a molecule and we have to check which of the following option is correct. So obviously it's a single correct question. Now to solve this problem, we need two important concepts in our mind. One is the electrophilic aromatic substitution reaction and second is the basic strength of nitrogen containing compounds. These two important concepts are there which you should know while solving this problem. Now if we go with option B, the option B says the nitrogen labeled as 4 is more basic than second but lesser basic than that of first. So if you look at the fourth nitrogen, this one, the lone pair on this nitrogen is delocalized one, right? That is, this is undergoing resonance like this. It is showing the resonance. But at the same time, if you look at the electron pair of second nitrogen, it is also under resonance on both the cases, right? It is showing resonance here also. It is showing resonance here also with both pi bonds. But if you understand this one, in the case of first ring, let's say this is the ring A, or we can say that this is the ring X, right? Just a second. This is the ring X, this is the ring Y. In the X ring, this is the ring X and this is Y. In the X ring, the second nitrogen, which is having lone pair, is giving us the aromatic character to the ring, right? Now the lone pair on the nitrogen, second one, yes, this lone pair is exhibiting the aromatic character to the ring. Because of that, the availability of lone pair in the case of second nitrogen is very less as compared to the availability of lone pair in the case of fourth nitrogen. See, both the lone pairs, that is on the fourth nitrogen and on the second nitrogen, both are in conjugation. But which one is more bonded? If you see, the second one is more bonded because second one nitrogen is giving the aromatic character to the ring. That means its availability for the basic character is nearly zero. Whereas in the case of fourth, even though it is in conjugation with the double bond, still it can show, it can exhibit a bit of basic character, right? That means yes, fourth is more basic than second. Now it is saying but lesser basic than first one. Now the first one is what? If you look at the first one, it is the double bonded nitrogen. Always remember that whenever the nitrogen atom is double bonded like this and it contains lone pair, this lone pair of nitrogen is always a localized lone pair. It is always a localized lone pair. That means it never shows conjugation, or we can say it is never involved in resonance. So if it is never involved in resonance, that means what? It's a free lone pair. In short, it's not a bonded lone pair. So any lone pair which is free or not bonded is always available for the base, right? That means it is more basic in nature. So yes, if we talk about the basic strength, if we talk about basic strength, the first one is more basic as compared to second one, and second one is less basic as compared to fourth one. This is correct. So yes, fourth is, if we talk about the fourth one, basic strength, just a second, yes, fourth one is more basic than second one, but because fourth one is in conjugation, so this is our delocalized lone pair. Fourth one is delocalized and first one is localized, right? So delocalized lone pairs are less basic as compared to the localized one. So option B is correct, right? Next, in option C, the given compound is having aromatic character. That is also correct because if you look at the ring X, in the X ring, this one, how many pi electrons are there? If you see, there are total of 1, 2, 3, 4, and 5, 6. To these one, there are 6 pi electrons. Hence, it follows the rule, Debye rule, right? And that means it is having the aromatic character. Now in the option D, basic strength of second, third nitrogen is more than fourth. If you look at the third nitrogen, again I have told you, if you do the conjugation, right? Let's try to do it. Let's try to make the conjugated structure and then we discuss. If you look at here, if this lone pair is undergoing resonance with this one, what do we get here? The resonating structure of this molecule will be like this. Right here the nitrogen is there, it shows double bond character here, the plus charge comes here, and this nitrogen gets a negative charge, the third nitrogen gets the negative charge. Now you see, during resonance the third nitrogen is getting negative, that means it is having more electron density now, and we know greater the electron density, greater the basic character. This is one explanation. Another one is that the third one is what? Third one is localized lone pair, and it is never in conjugation, it's a free lone pair, whereas the fourth one is bonded lone pair. Right? That means the option 3 is also correct, that the basic character of nitrogen 3 is more than nitrogen 4. Now remaining the option A. Option A says that compound A cannot give electrophilic aromatic substitution reaction. It is an incorrect statement. Why? Because if you look at the ring X, the X ring is aromatic in nature. Now simple point is we are talking about EAS reaction, that is electrophilic aromatic substitution reaction, and for that thing we need an aromatic molecule. So yes, ring first one is what? The ring first one is aromatic in nature. And for the electrophilic aromatic substitution reaction, even it can occur in the benzene without having any kind of group attached to it, right? That means a ring can show, a aromatic ring can show electrophilic aromatic substitution reaction even without the presence of an electron withdrawing group or electron donating group, right? That means this first ring, the X ring having an aromatic character, has the tendency to give us the electrophilic aromatic substitution reaction. So for us, option A is incorrect. That means which option to mark? Option A, right? So I hope you understood the problem very well, and you have learned a lot of things, that how we can deal with the nitrogen containing compounds basic strength, right? To solve more such problems, stay tuned to the chapter and stay tuned to the topic. Keep revising the topics which are given in your notes, and come back and solve more problems with me. So have a nice day. Thank you.